Hello and welcome to Maths with Jacob. This lesson will focus on simple patterns. A number pattern is a list of numbers that follow a certain sequence or rule. One of the simplest and most recognizable number patterns is the following: 1, 2, 3, 4, 5, 6, etc., etc. This represents the counting numbers starting from 1. Other examples: there are numerous other number patterns which are created using addition or subtraction, for example. For each of the following examples, describe in words the rule which is used to create each pattern. Example 1, 2, 4, 6, 8, 10, and so on. The rule: start with the even number 2, which is here, and keep adding 2 to each new number. This pattern is the set of even numbers beginning at 2. Example 2, 1, 3, 5, 7, 9, etc. Start at the odd number 1 and keep adding 2 to each new number. This pattern is the set of odd numbers beginning at 1. Example 3, have a look at these numbers here. The rule: start at 100 and keep subtracting 5 until you finish at the number 10. Example 4, this pattern here: start at the number 6 and keep adding 3 to create the next number, and this pattern just continues on. Patterns with pictures. Consider the following pattern: 2 brown squares, 2 yellow circles. 2 brown squares, 2 yellow circles. What are the next 2 pictures in the above pattern? If it was to continue with the same pattern, the answer would be 2 brown squares. Consider the following pattern. What is the next picture? You've got the circle, the square, star, circle, square, star, so that must be the circle. So it's the red circle. Using a rule to generate patterns. Use the numbers 1, 2, 3, 4, 5, 6 to apply this rule. Double each number and add 6. So if we double 1, that gives us 2. When we add 6, that gives us 8. If we double this, that gives us 4. Add 6, that gives us 10. Double this number to give us 6. Add 6 to give us 12. And you just keep continuing with that rule to generate the pattern. The next one: use the numbers 1, 2, 3, 4, 5, 6, etc. to apply this rule. Add 2 to each number and double the answer. So if you add 2 to this number, 1 plus 2 gives you 3. Double the answer to give you 6. 2 plus 2 equals 4. Double the answer to give you 8. 3 plus 2 gives you 5. Double the answer to give you 10. And you keep continuing with that rule to generate the pattern. Now let's look at some very special patterns. Consider the number pattern below: 1, 1, 2, 3, 5, 8, 13, 21, etc. The above is a world-famous pattern known as Fibonacci numbers. This pattern is evident in many areas in nature. So if you start with the two numbers 1, to get the next number you go 1 plus 1 equals 2. To get 3 you go 1 plus 2 equals 3. To get 5, 2 plus 3 equals 5. To get 8, 3 plus 5 equals 8, and so on. Now look at some areas where this occurs in nature. It's quite fascinating. If you have a tree, you start off with the trunk. So there's one trunk. See there? As you move up the tree, it splits into 2 branches. So that number 2 is a Fibonacci number. See there? As you keep moving up the tree, it splits into 3 branches. There's another Fibonacci number. And as you keep moving up the tree, you will see that it keeps splitting into the number of branches which are equivalent to Fibonacci numbers. Now this doesn't happen with every single tree, but it's amazing how many trees actually follow this pattern. Now this is a beautiful example here, and you'll see that all around in different gardens, etc. If you look at this beautiful flower, look at the number of petals on this flower. 3. 3 is a Fibonacci number. Look at this beautiful flower here. It's got 5 petals. 5 is a Fibonacci number. This here, if you look at it carefully and count the number of petals, you have 8. 8 is a Fibonacci number. Here is a beautiful sunflower. If you count the number of petals, you get 21. So 21 is a Fibonacci number. So there are some beautiful examples how the Fibonacci numbers occur in nature.